So in this program, let's try to draw a square by using turtle. Okay. So let's try to import turtle module. From the turtle module, I am importing turtle class. Since you need only one, you are going to have it. So actually you need screen also. So in order to get hold of the screen. So you can also put a star there. But anyway, if it is more than 3, then we can put a star. Otherwise, it is fine. So let us create an object called timid turtle equal to turtle and a screen object. Otherwise, what happens is if you don't create the screen object, then the screen will vanish. So you have to write exit on click. These two lines are going to be present in all the programs of Turtle. Even if I don't say, if you don't see them, they will be somewhere in the down. They always remember that these two lines are always going to be present. Now what we can do is, we want to create a square of 100 places width and 100 places height. So it is a square with all the sides as 100 places. So we will move the turtle forward by 100 places and then you can move it left or right by 90 degrees. So this is the number of places that we want to move, and then left or right means how much angle you want to turn. So you know that the angles in a square is 90. Therefore, I am writing 90. So this is the angle that I want to turn left. Now we are going to do it 4 times for all the 4 sides of the square. So now if you run it, now there is a positional argument missing distance. Somewhere there is a problem. Just see the line number. So line number 5. So line number 5, positional argument is missing. So forward 100 is right. Turtle dot forward 100 is right. So I exactly don't know what is the problem. Run it again. One minute. Line number 5 in module timid turtle dot forward 100. Have you taken it as a here it is not a turtle class, okay? So we have to put it there. So you can see that a square is being drawn, right? So run it again so that it will be shown. It is too fast. So you can see that a square is being drawn here, right? So this is a simple program. Here we are trying to do some warm up. Later we are going to build snake game and pong game using turtle, where we are going to use all these basics that we have learned here. So we will go step by step. Okay, thank you. Hi, let's now see how to draw a dashed line. So dashed line means line will be there, space will be there, again a small line will be there, again space will be there. So the length of the lines doesn't matter and the total length of the dashed line doesn't matter. All that matters is whether you are able to draw the line or not. So now how do you do it? So whenever any such problem comes to you, first thing is Google out. Okay, try to Google out. Obviously there will be a Stack Overflow question. You will find it. You read it. You should be able to find out all the functions or the classes that you have to use. And second thing is go to the documentation. And it is impossible. See, I have read the documentation, not completely, but whatever I need, I read it. So it is not easy to read the complete documentation before you use any module. So when whatever pieces that you need, you are going to read it from the documentation. So always Google out. Second thing is documentation. In the documentation, try to go to the part where you need it. For example, in this particular program, what we want is we want to draw a dashed line, and for that we need the pen controls, right? So in the turtle documentation, if I go down, if I keep going down, yeah, So there is something called as pen control section is there, and in that it is clearly given as pen down and pen up are there. So let's click on pen down. So if you see pen down, if you pull the pen down, then drawing when moving, which means while the turtle is moving, it is going to draw. And similarly, there is pen up. Okay, is when the pen is pulled up, then no drawing. So using these two methods, I can easily draw a dashed line. So pen down and pen up. Now let's go to the program and see how to do it. So this is standard from turtle, import turtle and screen. These turtle and screen are always required. And then we create a turtle object. This is standard in all the programs that we are going to see. And then screen, we have to create a screen. So now we are going to create a dash line. So we are going to move the turtle 10 places forward while moving up. See, by default pen will be down, so it will draw. So we are moving it forward 10 places, and then we will pull the pen up. Pull the pen up, and again we will move 10 places where that blank space will be created, and then again put the pen down. Right, and we want to do it for certain number of times. For that, we are going to put everything in a for loop. So you just want to count the loop. That is why I'm putting for underscore. When I put for underscore in, then it will just count the loops. If you want, you can put any variable name also there. Not a problem. So 15 times it is going to be repeated, and 15 times you are going to get a line which is 10 places, which is drawn, and then a gap of 10 places. Okay. So actual length of the line doesn't matter. Let's run it. You can see that there is a dash line being printed, right? If you want to increase the length, you can increase the number 15 to some other number, and if you want to alter these sizes, you can alter. So there is a small question I would like to ask. Without using pen down and pen up, is there any other way by which you could have drawn this dotted line? Just think about it for a minute and then answer. Without using pen down and pen up, is there any other way that you could have drawn this dashed line? Yeah, so one thing is you can change the colors of the pen, black and white. So black for some time, white for some time, black for some time, white for some time. If you draw like this, there will be a dashed line. See, there are many ways to do the same thing. It doesn't see ultimately in the output you have to see the dashed line. You can use any method that you like. So use your creativity. As you are going to design games, then you can do your own things and you can actually write your own games. Okay, thank you. Let's now draw a figure similar to this or exactly this. So here if you see there is a triangle, and then there is a square outside it, and then there is a pentagon. Like that the number of sides are increasing, and finally we want a diagram with 10 sides. Okay, so this is the diagram that we want to draw. So what is the logic that we are going to use in this diagram is, let's go next bit. Okay, so here if you observe it, for a square, how much right from here, if you are trying to do a square, how much right you should rotate? It is 90 degrees. And for a pentagon, what is the angle that you should rotate to get a pentagon? It is 72 degrees. If you observe it, it is nothing but 360 divided by number of sides, which is 4 here, and 360 divided by number of sides, which is 5 here. That is how we got 72. So anyway, this is not a mathematics class. Here we are trying to do a Python program. So you can directly assume that these formulas are right. And let's go to the program to draw this using a turtle. So first we are importing turtle and screen from the turtle module. and we are creating a new object of turtle class. And then anyway this line is common everywhere. You have to put this screen, catch hold of the screen object, and you have to say exit on click. Otherwise the screen will be disappearing immediately, so you will not be able to see it. So now we have to take 360 and divide it by the number of sides, and that is how you are going to get the angle by which you have to rotate either left or right. Let's say we are going to rotate by right always. So we start from here, right, like that. Okay. So let's move it. Let's assume that the size of each side is 100 places. Okay. And we can rotate it by right. We can rotate it to right by some angle. And we are going to do it for all the sides in a for loop. So one thing, if you observe it, we are moving forward and moving right and turning right, and again moving forward, turning right. But then this angle need not be calculated in the for loop, right? So this can be kept outside the for loop. It can be calculated once. Now let's try to do it for a pentagon and see. Number of sides equal to 5, and let's try to indent it. Okay. Let's try to run it and see what happens. For every 72 degrees it is rotating right. Now if I run it, you can see that there is a pentagon. Run it again. You can see that there is a pentagon drawn, right? Now what we want to do is, we want to do a triangle, then square, then pentagon, hexagon, decagon, all like that, one after the other. So we have to run this many times. So let's put it in a function. Let's put this code in a function and let's call it many times for sides equal to 3, 4, 5, 6, so on, 10. And let's call that function by passing number of sides. In a for loop we'll call it, okay? Otherwise you have to draw a nested for loop here, right? See, you can do it many ways. Here you can put a nested for loop. Outside you can put a for loop where the number of sides will go from 3 to 10, and inside you can put this for loop. Otherwise write a function and you can call the function those many number of times. So we are going to call a for loop. Now the for loop is going to run from 3 to 10. Therefore in the range you have to give 3 to 11. In the range we are going to give 3 to 11. And then we are going to call this method, for this function, draw shape, and the shape is going to be passed the number from this range, one number from this range, and it is going to take that number, calculate the angle, and then it is going to do it for those many number of sides. It is going to go forward and turn right. Therefore each shape will be printed one by one after the other. First triangle, then square, then pentagon, like that. Okay. Now first triangle is drawn, then square, then pentagon, like that. All the 10 are actually drawn. It doesn't matter whether you move left or right, you can move any sides. So finally we got whatever we want, but there is a small thing that we want here. I want all these shapes to be of different shapes, different colors. Okay. So how do you get the colors in turtle? So you can Google it out. So When you Google it out, the website that I found is trinket.io. Trinket.io contains the colors. You just Google it out as turtle colors Python. Okay, don't forget to add Python, otherwise you'll get the actual turtle colors. If you type turtle colors Python, you are going to see this particular website. In this website, if you click on any color, it is going to give you a name. Okay, that name is nothing but the name of the color, and if you use that name as a string to the color method of the turtle class, then you are going to change the color. Okay, so I have taken 10 colors. And I have made a list of it, and I am going to put all those 10 colors in the list. Okay, that list has disappeared actually. Okay, so you do it as an exercise. You try to take the list, and in the list you try to put all the 10 different colors, and then you randomly just take a color and you change the color of it. Okay, okay, stop it. Okay, thank you. Hi, in this program, let's try to draw a random walk. So, what is a random walk? If you go to Wikipedia and see, it will give you the definition. So, when we are taking steps randomly in every direction, that is random walk. Okay, so sometimes we may go to right or left or east, west, north, south. If you do that, then that is random walk. And there are many applications for random walk. If you go to Wikipedia page and read it, it shows that it can be spending of a gambler, or the motion of a molecule, or brain activity, how it is happening. They all can be modeled after random walk. So let's try to do random walk using turtle here in a Python program. So first, so this skeleton is same. So what I have done here is I have imported turtle and screen, and on this screen I am doing exit on click. This is same for all the programs. And now I have a list of colors so that I can randomly color every step. For every step I want a different color. So I am having a list of colors. So I can use that list of colors later. And also if you see it, I have imported random also. You know that random walk has to have randomness. For that I am using random. And now I am creating a list of directions: 0, 90, 180, 270. Each one actually specifies one direction. 0 is east, 90 is south, 180 is north, and 270 is west. So each of them specifies that. You have to read the documentation to understand this. Okay, so I'm not showing the documentation, but in the documentation they are all going to be present. Okay, so try to understand the program, and if you need more details, go to documentation once. Now I am moving the Tim 30. Tim is the turtle here, so I am moving Tim 30 places forward, and then set heading is used to change the direction. So in order to get one of the random directions, I will use random module there. So random dot choice, we can pass a sequence to it, and the sequence we are passing is directions list here. It is going to every time choose a different direction randomly, and then we are going to move the Tim in that direction. So I want how many steps I want. Every step is 30 places. So how many steps I want, I'm going to put it in the for loop. If I put 200, it is too many, but we will speed up turtle. Now if you run it, you can see that turtle is moving randomly in all the directions for 200 places. Right? So what I want is, in the diagram which you have seen, we have seen that the thickness of each line, each step is much higher than the thickness we are shown here. So I want to set the thickness. Again, you can go to the documentation and see how to set the thickness, or you can go to Stack Overflow. But the method that we are going to use is pen size. Now, pen size can be anywhere between 0 to 100. So we are going to use a thickness of 15. And also, I want random color every time for every step. So again, I am choosing a random color from the colors list by using random.choice. Random.choice colors. Now you can see that thickness has increased and it is taking some time. Actually, it has gone up out of the screen. And it is taking some time. Let's do one thing. Let's try to increase the speed of it. So again, if you go to the documentation, there is a method called speed. So to the speed, we will give fastest. So you can give fast, slow, medium, all that. I'm giving fastest to speed method of the turtle. Now if I run it, you can see that it is very fast. It will complete it soon. Okay. So all the 200 steps have been completed and this is what output we got. Thank you. So if you look at RGB Calculator, which is in W3 schools, they have given us how different colors are formed by mixing three base colors, red, green and blue. Okay. So if you say the value, if you increase the value of red, you are going to get some red color. And if I mix it up with green, you will get a different color. And if I mix it up with blue, it is going to be a different color. So we can generate random colors by setting the value of R, G and B with some random number between 0 and 255. Okay. So here red is 107, green is 101, blue is 144. So with this knowledge, we can randomly generate colors. Okay. So if you go to the documentation of this, let's go to documentation once. Turtle Python documentation. There you can see color. If you scroll down, here there is color. 1 minute. Yeah, color is there. So color or pen color are used to change the colors of the pen. So we are going to use these methods and we are going to go to color ones. So you can, for the color, you can either give a string or an RGB. So this is important. Just try to understand it. If you want to change the color of the turtle, you can either give a color string, right, like deep blue, red, or deep orange, something like that. You can give color string. Otherwise, you can pass a tuple. So if you understand this, clearly see this, color is taking as an argument a tuple, and this tuple can be any value from 0 to 255 of red, green, and blue. Right? So it is taking a tuple. So now we will create tuples and randomly generate colors. We will go to the program. In the previous program that we have seen in the last video, I have made a small change that we are importing turtle as t and we are putting turtle.t.turtle and t.screen. So what we will do is we will try to change the color mode. So we have to change the color mode in order to accept those numbers 0 to 255. It is also in the documentation, you can see that. So change the color mode to 255. It means that we are now changing the color of the turtle by using a number RGB in the range 0 to 255. So earlier we have used 10 colors, right? So we have used 10 colors. Now we don't want to use only 10 colors. We want to generate any color randomly. So we deleted it. And now we are writing a new method called random color. It will give us a tuple of RGB in the range 0 to 255. So we are going to use random.randint in order to generate a number from 0 to 255. And let's call it red. Similarly, we will do it for green and red, green and blue. Now we will make a tuple using this. We will form a tuple. A tuple called random color, and we will put this RGB in that. And then wherever we have used the color, we are returning that particular color. And now wherever we have used the color from the list, here in the color we have used the color from the list, right? So we are changing it with the random color. So when the random color is called, it is always going to return a different random color. And now our turtle will get different color. This is how you can generate random colors. Now if you see it, it is not just 10 colors. We are getting many colors here. Okay, so we got all different colors, not always those 10 colors that I have used in the list. Okay, thank you.